Atmosphere allows you to create a more realistic and immersive environment in your Roblox games. We can add this in Roblox Studio by clicking the plus button next to the lighting service, then selecting Atmosphere. After that, add a skybox into the lighting service if there isn't one there already, or else the atmosphere won't work. We can customize the atmosphere by selecting it, then looking at the Properties menu, which can be enabled through the View tab at the top left of the screen. After describing how each of the properties work, I will explain how we can update the atmosphere through code, including how to create custom zones that automatically change the atmosphere for players that enter the area. The first property is density, which allows you to change how clear the sky is on a scale of 0 to 1. A higher density value makes it more difficult to see objects and terrain that are farther away. After that is offset, which changes how the environment blends with the lighting into the background on a scale of 0 to 1. When the offset is higher, it becomes easier to see objects and terrain that are farther away. Because the density and offset properties change the visibility of the environment, it's important to make sure that they work together to achieve the intended effect for your game. The haze property creates a foggy mist throughout the sky on a scale of 0 to 10. A higher haze value increases the amount of mist in the atmosphere, starting with the horizon before covering most of the sky. After that is the color property, which changes the hue of the atmosphere. This is most noticeable with a higher haze value. On the other hand, if the haze property is set to a lower number, updating the color of the atmosphere will have less of an effect. From here, we have the glare property, which changes the intensity of the sunlight on a scale of 0 to 10. Glare only works if both the haze property of the atmosphere object and the brightness property of the lighting service have values that are greater than 0. A higher glare value causes the sun to glow and makes the sunlight affect the environment to a greater degree. Finally, there is the decay property, which only works if both of the haze and glare properties have values that are greater than 0. Decay changes the hue of the atmosphere around the sun. Then it slowly fades into the value of the color property as it goes farther from the sun. Also, it's important to keep in mind that the time of day, brightness, and most of the other properties of the lighting service affect the appearance of the atmosphere in your game. We can change the values of the atmosphere's properties while the game is running through scripts. Updating the atmosphere from a server script changes it for everyone in the game at the same time, whereas updating it from a local script only changes the atmosphere for a specific player unless the code runs for multiple players at the same time. To update a property, we need to tell the script where the atmosphere object is in the game, which in this case is the lighting service. After that, we will tell the script to essentially select the atmosphere object and update the property that has this name, which is density in this example, to a new value. This format applies for all of its properties, and can be included during functions so that the atmosphere can be updated whenever you need it to. To make it easier to change the atmosphere when players enter specific areas of the map, we will be using Forever HD's Zone Plus module that provides tons of useful and performant features for creating custom zones. It will be included in the resources section of this video's description, alongside the final product that we will create in the next few minutes. After getting the Zone Plus module from the Creator Marketplace, we can add it to our game by enabling the toolbox from the View tab in Roblox Studio, then opening our inventory and selecting Zone Plus. We can then move the Zone module script from the workspace to the replicated storage service. After that, create a local script in the Starter Player Scripts folder, which we will use to locally update the atmosphere for players that enter the custom zones. Before we write some code, we will need to set up the zones in the workspace. Start by creating a folder in the workspace called Atmosphere Zones, which is where all the zones will be placed so that it's organized and easy for the local script to find. You can create a zone by adding an individual part to the Atmosphere Zones folder, or by storing multiple parts inside of objects that are not base parts, such as models or folders. That means that this model named Example1 creates a zone which includes every single part in the model. On the other hand, these two separate parts create two completely different zones that cannot be expanded using additional parts. For both of those examples, all of the parts must have the CanQuery property enabled. Any parts that don't have it enabled won't be able to update the atmosphere. You can also create zones through C-frames inside of a script, but we won't be doing that for this example. From here, you can resize any of the parts in a zone to establish where the player needs to be for the atmosphere to change. If it isn't allowing you to move or scale parts through the map, make sure to disable the collisions option from the Home tab at the top left of the screen. Because a player will need to be standing inside of a part in the zone for the atmosphere to be updated, it's recommended to set the transparency property of the part to 1 so that it becomes invisible, disable the Can Collide property so that players are able to walk through the part, and then enable the Anchored property so that it doesn't fall into the void. Next, we will add attributes to each of these zones so that we can more easily let the local script know which properties of the atmosphere should be updated when a player enters each zone. The quickest way of doing this would be to paste this in Roblox Studio's command bar, which will be included in the resources section of this video's description. After clicking enter, attributes will be automatically added to every item on the first layer of the Atmosphere Zones folder that correspond with each property of the atmosphere object. Another option is to manually select the container of a zone, look at the Attribute section of the Properties widget, select Add Attribute, then create attributes that have the exact same name and type of value as each property of the atmosphere, which would be color 3 for the color and decay properties, and number for the rest of the properties. If you don't want the zone to update certain properties of the atmosphere, such as offset or decay, you can manually delete an attribute by selecting the gear icon and clicking Delete. From here, update the remaining attributes to the values you want the atmosphere to have when a player enters the zone. To temporarily visualize what it would look like to enter the zone, I would recommend updating the properties of an atmosphere object in the lighting service, then inputting those values for the attributes of a zone when you find a combination that you like. Now we can open the local script we created in the Starter Player Scripts folder and complete the final steps. Again, the final product will be included in the resources section of the description if needed. We will start by creating variables for these 3 services because we will need to access each one for different reasons. The replicated storage is where we stored the zone module, which we can require to use the custom functions that it provides. The lighting service is where the atmosphere is located, and the tween service will be used to create a smooth transition for the atmosphere's properties when a player enters or exits a custom zone. We will also reference the Atmosphere Zones folder in the workspace, so the local script will know which objects it should use to create each zone. Then, we can create a table named Default Atmosphere to store the values of each property of the atmosphere as soon as the game starts, which is what the atmosphere will transition back to when a player exits a custom zone. Also, because we created a variable for the atmosphere earlier, we don't need to repeat game.getServiceLighting.atmosphere every time we need to reference it in the table. Now we can create a function that will be responsible for adding the functionality to each zone. First, we need to activate this function while telling it which objects are zones. We can do this by looping through every item on the first layer of the Atmosphere Zones folder, calling the function with this name, then sending through each item to the function. We will also add this to make sure the function is called for any new items that are added to the first layer of the folder, just in case you want to create or enable new zones while the game is running. Then, we'll add a parameter to the parentheses of the function, which is a word that acts as a placeholder for talking about the items that are sent to it. This is where we will start using the features that the Zone Plus module provides, beginning with creating a custom zone based around the object that was sent to the function. Next, we will bind the zone to a group called Enter Only One Zone at a Time with this exact capitalization, which prevents players from activating 2 or more zones at the same time, or else the effect might not work as intended, especially with overlapping zones. From here, we can reference the custom zone and use the local player entered event of the module to activate another function whenever a player enters a zone. This is where we will use the tween service on the atmosphere object to update its properties. The first value we input is the object that is being animated, which is the atmosphere object in this case. Then, we can define the characteristics of the animation, with the amount of time in seconds that it will take to complete the animation being the first setting. Finally, the third value is the goal of the animation, which is what the atmosphere should look like after the animation is done. Since the createZone function was activated separately for each zone in the folder, we can reference the attributes that we created earlier by calling getAttributes on the object that was sent to the function. After that, the localPlayerExited event will activate another function when a player exits a zone, with the only difference being that the new goal is based on the values from the default atmosphere table. If you want to customize the tween surface animation some more, here's an example of what that might look like. To learn more, please refer to the additional resources in this video's description. The final additions to this local script revolve around handling cases where a zone has been removed from the Atmosphere Zones folder. We will call the destroyZone function in two ways, with the first being from an event that is activated when the zone, or the folder that contains it, is moved to another part of the game. We will also create a variable that will store this event connection, so that we will be able to tell the local script when it no longer needs to listen for the zone and the folder to be moved anymore. Then we can check if the container is no longer inside of the folder before calling the function. Alongside this, we will call the same function when a zone inside of the Atmosphere Zones folder has been destroyed, so that the custom zone is still cleaned up. We don't need to store a connection for this event, because when an object is destroyed, all of its event connections are automatically disconnected. Now, we can reference the custom zone, unbind it from the group, then destroy it. We're using a lowercase version of destroy because this is a custom method for disconnecting event connections related to the Zone Plus module, which is completely different from the objects we can see in the Explorer. If we needed to delete an object from the Explorer, we would still use the uppercase version, which is Roblox's built-in destroy method. From here, we can disconnect the other event connection and set the variable to nil, which basically clears the variable, so that the script knows it doesn't need to listen for the zone to be moved anymore. If it's added back into the Atmosphere Zones folder at any point, a new custom zone will be created for it again, and all of the events will be reconnected so that it'll be able to update the atmosphere. Leave a like on the video if this was helpful, consider watching the videos on screen for more, and if you have any questions, concerns, or suggestions, post a comment down below. As always, have a wonderful day.